Welcome to Lesson 1-8, Exploring Transformations. So we're going to start out with some terms. These are ones that hopefully you're familiar with from previous classes. The first one is transformation. This is a change in the position, size, or shape of a figure. The types of transformations are translations, reflections, compressions, and stretches. Now there are other types, but these are the ones we're focusing on here. A translation is a slide. It moves each point in the figure the same distance and in the same direction. A reflection is a transformation that flips the figure across a line called the line of reflection. A compression pushes the graph towards an axis, and a stretch pulls the graph away from an axis. So when you're graphing, there are certain operations that we do to the ordered pairs in order to complete these types of transformations. So let's see what those are. Now, the translation ones should make a lot of sense. So if you're moving it to the right, you're going to add a number to the x value. If you're moving the object to the left, you're going to subtract a number from the x value. If you're moving it up, you're going to add to the y value. And if you're moving it down, you're going to subtract from the y value. Now, you can do combinations of these, so you don't have to do just one, but that's how the translations work. For reflections, we're going to be multiplying by -1. So if we go across the y-axis, the x value is multiplied by -1, which makes sense if you really think about what's happening on a graph. If I have something in first quadrant and I want to move it to second quadrant, the x value is going to become negative. If I'm going across the x-axis, I'm multiplying the y values by -1. So if I have something in first quadrant and I want to move it down to fourth quadrant, the y value is going to change. And for any stretch or compression, if it's a vertical stretch, you're going to multiply the y values by whatever factor it is. If it's a horizontal stretch or compression, it's the x value being multiplied by whatever factor it is. If the factor is less than 1, that would be a compression. If the factor is more than 1, then it's a stretch. So let's take a look at some examples where we have to find points and actually find their transformed places. In example 1, it says perform the given translation on the point 2, -1, give the coordinates of the translated point. So in part A, it says move it 4 units to the left. So our original point was here, and I have to move it 1, 2, 3, 4 units to the left to where this point is. So 4 units to the left, I'm going to take the x value and subtract 4 and get a new x value. So my point is -2, -1. For part B, it says move the point 2 units to the right and 3 units up. So we're starting at this original point, and I go 1, 2 units to the right, then I go 1, 2, 3 units up. Okay, so the x value I'm adding 2 because it's 2 units to the right. Right is a positive direction. And then the y value I'm adding 3 to because it is going up, which is another positive direction. So the point that I end up with is 4, 2. So let's take a look at another one. This time what they're going to do is they're going to give me a graph. I have to pick points and actually move them in a way that they're describing. In example 2, it says use a table to perform each transformation. Use the same coordinate plane as the original function. They want me to translate this 2 units down. So what I did is I picked points on my original function. I picked -2, 4, -1, 0, 0, 2, and 3, 2. Now, you can pick other points, but you should at least have this point where it changes direction and this point where it changes direction. And I picked these specific points, especially this one, because it tells me what's going on with this diagonal line. And it is perfectly at that point right here. Now, I could have picked any other point on here, though. So the 3, 2 point could be any of the other points on this line. So translating 2 units down, that's a change in the y value, and the y values have to decrease by 2. So I subtracted 2 from each y value. So I get -2, 2, -1, -2, 0, 0, and 3, 2. And then all I have to do is graph it. So I graphed my new points, and I got this pink function here. Let's take a look at another example. Okay, it says use a table to perform each transformation, y equals f of x. use the same coordinate plane as the original function. And this time they want me to reflect across the y-axis. So notice it's the same graph from the previous example. I'm using the same original points, but now we're reflecting across the y-axis, meaning anything that's on the right side is moving to the left, anything that's on the left side is moving to the right. That's going to affect the x values of my point. And reflections just mean multiply by -1. So my x values are changing their signs, and I get these new points. And all I have to do is graph them. And when I connect them, I get this pink function right here. So that's my new graph. Let's take a look at one where we have to do a stretch or compression. In example 3, it says use a table to perform a horizontal compression of y equals f of x by a factor of 1/2. Use the same coordinate plane as the original function. So this function is a little different. We still have this diagonal type part over here, and I picked the point -1, 3 on there. We have where it changes direction here. I picked 0, 0. You can pick a point on this curved area, but it's hard to find one that's exact. So I just picked this point here where it changes direction again, which is 2, 2. And I did also pick 4, 2. Now, it's a horizontal compression by 1/2, so I'm going to multiply my x values by 1/2. So I did that to get these new points. Notice 0 times 1/2 is still 0, and I got these points here. So the graph would look like this. This pink line represents the graph made by graphing those new points. Let's take a look at a word problem where they want us to apply transformations to a situation. In this example, it says recording studio fees are usually based on an hourly rate, but the rate can be modified due to various options. The graph shows a basic hourly studio rate. Sketch a graph to represent each situation below and identify the transformation of the original graph that it represents. So in part A, it says the engineer's time is needed, so the hourly rate is 1.5 times the original rate. So the hourly rate is talking about the fees here, and it's saying it's 1.5 times that fee. So that's going to be a vertical stretch because we're taking our fee and multiplying it by 1.5. So all we would do is pick certain points on here like 0, 0, 5, 150, and take the y values and actually multiply by 1.5. And when we do that, we will get this graph. Okay, so I had 0, 0, 5, 150. 150 times 1.5 is 225. So that would be here. Okay, and you can pick other points if you want. I picked this one in particular because it's right where the grid lines cross, but you could pick others. We have one more example. Let's see what it is. In this one, it's the same situation, except instead of changing the hourly rate, they're saying that a $20 setup fee is added to the basic rate. So all that's doing is it's adding a flat fee of $20 before the rate kicks in. So that's just going to take the 0, 0 point and move it up to 20. So it's a vertical translation up by $20. So the fee has just increased by $20 every single time. So that graph will look like this. I just moved each point up by 20 on this pink line. Okay, so this was here at like 180, and now it's up here at 200. It was at 0, now it's at approximately 20. So that's all I did with that one. So that's it for this lesson. Let me know if you have any questions.